So we're going to talk about exponents. Exponents just make life easier, so you can write them a little bit simpler. And we're going to start out with sort of what we call these various pieces. So I'm going to start out with x to the a power. Start real generic. Now the x portion we refer to as the base, and sometimes we'll refer to it as the root. At the beginning of the class here, usually we call it the base. Now the superscript up here, or the a, we refer to as the exponent. Sometimes, when we're dealing with radicals and things, it's that a is referred to as the power. And later in the semester, we will run into something called polynomials, and a will be called the degree. For right now, we just need to know exponent and base. So let's define what we mean by this. We're going to start kind of with letters, and then we'll move into numbers, so it'll make more sense. So x to the a power means x times x times x, and then dot, 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 times x. And this is going to multiply the base times itself exactly a times. Okay. So enough of the theory. Let's get to the actual practice. Let's start here. 2 to the 5th power. Now in this case, the 2 is the base, and the 5 is the exponent. And by definition, over to the right there, this means 2 times 2 times 2 times 2 times 2, 5 times. And when I multiply all that up, I end up with 32. Now, sometimes you get going on exponents and you see the 2 and the 5 and you think multiply and you multiply and get a 10 or something. You want to make sure that you don't do that. Actually write them out. That way you can really kind of see what you have and you don't make mistakes like that. It's very common to make those kind of mistakes on tests. Let's do another example. We'll say 5 to the 3rd power. In this case, the base is 5. And the exponent says multiply it times itself 3 times. And when I multiply that out, that gives me 125. Let's try another one. 4 to the 2nd power. Sometimes we say 4 squared. It's going to give me 4 times 4, which is 16. Next up, we'll say 7 to the 1st power. That means take 7 and multiply it times itself just the one time. So 7 to the 1st power means 7. So, next up, what if we want to square or put an exponent on a negative value? So let's take negative 3 to the 2nd power. Notice I have parentheses with this, and that does matter. This actually becomes negative 3 times negative 3. And we know a negative times a negative gives us a positive 9. Let's see what happens when we multiply, or when we have negative 3 to the 3rd power. That means go negative 3 times negative 3 times negative 3. That's going to equal 9, because negative 3 times negative 3 is 9, times another negative 3, which gives me negative 27. Now notice, the first example, the negative 3 to the 2nd power there, is equal to a positive 9, but negative 3 to the 3rd power gave me a negative 27. Let's take negative 2 and raise it to the 4th power. That's going to give me negative 2 times negative 2 times negative 2 times negative 2. Now I'm going to multiply the first 2 to get 4 times negative 2 times negative 2. Now I'm going to multiply the next 2. 4 times negative 2 is a negative 8 times negative 2. And now I have a negative times a negative gives me a positive 16. Now, I'm hoping you can see a pattern here that when I have a negative base, if the exponent is even, I get a positive result. When the exponent is odd, I get a negative result. All right, let's do an order of operation problem to show this parenthesis thing. So 5 minus 3 to the second power. Now you might think that that 3, that negative 3, is going to get squared and become the positive 9, like in the earlier example, but it's not. Because it's not in parentheses, it's actually going to become 5 minus 9. That does not change to a positive value. So 5 minus 9 gives me negative 4. This is versus this problem. 5 plus, parentheses, negative 3 squared. Now you can see the negative 3 in the parentheses, and that actually does become negative 3 times negative 3. So that gives me 5 plus 9, which overall gives me, of course, 14. Please note the differences between these. It's really going to matter later when we start dealing with equations and things. And that is exponents. So we're going to talk about exponents. Exponents just make life easier, so you can write them a little bit simpler. And we're going to start out with sort of what we call these various pieces. So I'm going to start out with x to the a power. Start real generic.